there are many tens of thousands of people who gave their life's work towards trying to achieve that dream of what comes after flat media. What we see in the movies, that's the North Star for us of what we want to achieve. So we made a lot of different inventions, and we filled up dumpsters full of failed experiments, and then eventually got to that MVP, which for us was this device called the Looking Glass. My name is Shawn Frayne, and I'm co-founder and CEO of Looking Glass Factory.
This is Code Story, a podcast bringing you interviews with tech visionaries who share in the critical moments of what it takes to change an industry and build and lead a team that has your back. I'm your host, Noah Labhart, and today how Shawn Frayne brought to life the thing you see most in science fiction movies, the hologram. All this and more on Code Story. Shawn Frayne grew up dreaming of being an inventor. His heroes were the inventors of yore, like Thomas Edison. Growing up, he was inspired by TV shows and movies like Beyond 2000 and Back to the Future 2, specifically when Marty McFly gets eaten by the holographic shark. Believe it or not, to kick back and relax, he thinks about inventing other things while having a cold beer. Shawn recalls that Edison once said, "All you need to invent is an imagination and a pile of junk." And he lives by that, with the added part of having his kids around in the mix. He studied physics at MIT, and post-graduation, while everyone was heading to Silicon Valley, he was curious if anyone could still be an inventor. He decided to pursue it, and invented a few things before eventually cycling back to the inspiration from Back to the Future, the hologram. This is the creation story of Looking Glass Factory.
My co-founder Alex and I started Looking Glass Factory to really prove that it was possible to make holographic displays in the sense of what you think of as a hologram or a holographic display in a movie like Iron Man or Minority Report or Back to the Future 2, where you have something three-dimensional that a group of people can gather around and see and interact with as if you were looking at the real thing. But of course, instead of that hologram being made of atoms, it's made of a field of light. And it turns out that a lot of folks have chased this dream over the years. The only thing I can think of that's comparable is the chase for human flight, where you had folks knew it was something to be achieved for many, many centuries, the dream of human flight, but no one quite knew how to do it. So you have all those old movie reels that I'm sure you and the listeners are familiar with, where you got, the guy with the hopping car with the fan on top. You have people jumping off the cliffs, trying to achieve this dream. And then all of a sudden, the Wright brothers figured it out. And that's the same way that we essentially achieve human flight 100 plus years later. Same thing goes for holographic display. Over the last 100 years, going all the way back to the Lumiere brothers who pioneered film, they had a dream of making a volumetric or holographic cinema. But the technology at the time wouldn't support them actually achieving that. But they did achieve cinema, which is a big enough thing in and of itself. But, going through the subsequent 100 years, there are many tens of thousands of people who gave their life's work towards trying to achieve that dream of what comes after flat media, how you can have that holographic display. And it's why it's so prominent in all of the sci-fi movies we all love, because it is one of the few common technological human dreams. And we're in the very fortunate position in Looking Glass Factory to be at a time where there's a lot of three-dimensional content that's trapped on two-dimensional screens, and where computers are fast enough to actually run and calculate full holographic light fields on the fly, and display modules that we can use have enough density thanks to gamers that demand high density, high refresh rate screens, and everything happening in the world of tablets and phones, all of that has fed into it finally being actually possible to make commercially viable holographic displays. So that's what we do. We make holographic displays.
This episode is sponsored by Vanta. You're a startup founder. Finding product market fit is probably your number one priority. But to land bigger customers, you also need security compliance. And obtaining your SOC 2 or ISO 27001 certification can open those big doors. But they take time and energy, pulling you away from building and shipping. And that's where Vanta comes in. Vanta is the all-in-one compliance solution helping startups like yours get audit ready and build a strong security foundation quickly and painlessly. How, you ask? Vanta automates the manual security tasks that slow you down, helping you streamline your audit. And the platform connects you with trusted VCSOs to build your program, auditors to get you through audits quickly, and a marketplace for essentials like pen testing. Join over 8,000 companies, including many Y Combinator and Techstars startups who trust Vanta. Simplify compliance and get $1,000 off at vanta.com/codestory. That's VANTA.com/codestory.
Tell me about your MVP. So that first product you invented, how long did it take to build, and what sort of tools did you have to use to bring it to life?
I mean, it's a meandering path to, in a small way, we made that wide variety of inventions that attempted to make holographic displays. So we have these old footage reels from a few years ago where we had flapping devices, we had spinning things and whatnot to try to achieve that vision of a three-dimensional, field of light that a group of people could see without, the important distinction of what we do versus what other folks at Microsoft with HoloLens or Oculus at Facebook and so on that they do, is that our systems don't require you to put something on your head. In a lot of ways, gathering around a holographic display is more like, gathering around a campfire or gathering around a radio. These things that we're used to doing in our families and in our businesses. And that's sort of how we see this interface of holographic display developing. So we made a lot of different inventions, and we filled up dumpsters full of failed experiments, and then eventually got to that MVP, which for us was this device called the Looking Glass. And it combined a whole lot of elements that we learned about from our previous experiments with those spinning and flapping and floating systems to make something that we could produce by the thousands and get out to, all the hologram hackers in the world that were just waiting for a system like this.
So in that MVP process, obviously you went through a ton of iteration and landed on the MVP. But how did you decide what the MVP was going to include, and what sort of trade-offs did you make in the short term to say, okay, we're going to build this and not these other three things? And how did you cope with those decisions?
In the chase for the hologram, you have a few branching paths you can take. So the most relevant, I think, to most of the listeners would be, did we want to achieve the Tupac hologram, which was all over the internet. If you search for hologram on the internet, you'll probably pull up the performance by holographic Tupac at Coachella some years ago. And that's a two-dimensional reflection. It's very stunning as stagecraft, but it's essentially an extremely refined two-dimensional reflection that works because you have so many viewers so far away from the stage that they don't have any depth perception of what's going on there anyway. We made a decision early on that our systems were going to be genuinely three-dimensional in the way that the real world is three-dimensional. Like if I'm looking at a cup of coffee right now, and this cup of coffee is real to me in a way it wouldn't be real to you if you were looking at a picture of it, or if we were on a Zoom call and you were seeing it represented by the pixels of your laptop, because I'm seeing it three-dimensionally. And more than that, all of the light rays from the world are bouncing off of the ceramic of the cup and the liquid of the coffee with specular reflection and all these other details that my eyes are picking up and that my brain calculates into being this real three-dimensional thing. And so, that was one of the very early forks that we decided was critical to our MVP, was that it had to be genuinely three-dimensional and not a pseudo hologram, in the sense that the really compelling but different Tupac style hologram, which is called Pepper's Ghost. It's an effect from long ago, I think the 1800s. Other factors were it had to move, so it wasn't going to be purely static. So my background is actually in conventional holography, where you take a laser or, a source of coherent light, typically represented by a laser, and you use that to create an interference pattern at the order of the wavelength of light on a very dense sort of glass slide, a holographic film medium. And the end result of that conventional, traditional holographic exposure is static. It's sort of like a laser photograph. You can see these on some credit cards, the little bird and whatnot, the holographic foil capture that you have there. That's similar what you get from conventional holographic techniques. And that just wasn't enough for any of us who were chasing this dream. The dream is what you see in those movies. And when Tom Cruise in Minority Report is looking at a memory of his son that died, it's not a photograph, it's not a laser photograph, it's a moving memory. So those two things were the key driving factors in what would, eventually become our MVP or those first prototypes of the looking glass. It had to be genuinely three-dimensional, and it had to be dynamic and moving, like the real world is, like life.
I hear a pretty consistent theme so far of there's a lot of capturing dreams that were shown in cinema and bringing them to life. Has that been a big driver of helping visualize what you want to bring to life?
Oh, for sure. I mean, I think everyone says this that's doing something of this sort, but sci-fi in a lot of ways leads the way. It doesn't have the nuanced refinement that making the real thing has. And of course, there's some things you can do in the movies that you can't do with real physics, but the spirit of what is embodied there is truly what we continue to attempt to achieve in our company. What we see in the movies, that's the North Star for us of what we want to achieve. On that note, a lot of what you see with holograms in movies has to do with allowing people to connect with one another, either by seeing a message from someone far, far away, a holographic message, or, by seeing a engine that Hiro Hamada in Big Hero 6, or a robot that Hiro Hamada in Big Hero 6 is working on in his light field holographic display in his garage. All of these things have to do with ways for people to create, and especially ways for people to be able to connect with one another when they're not in the same physical space together. We've been thinking about that more deeply these days than we have in the past with everything going on in the world now.
This episode is sponsored by Kinsta. Between juggling client meetings, managing your website, and keeping up with everyday tasks, who has the time to stress out about website security? Well, with Kinsta, the technical stuff is taken care of, so you can focus on what you do best. Kinsta provides managed hosting for WordPress, offering lightning-fast load times, top-tier security, and unmatched human-only customer support. Whether you're a business owner, web developer, or running a digital agency, Kinsta makes managing your website easy and efficient. Kinsta provides enterprise-grade security, being one of the few hosting providers for WordPress with SOC 2 and other certifications, guaranteeing the highest level of security for your website. Thanks to their unlimited free expert-led migrations, Kinsta ensures a smooth transition for you from other hosting providers. Customers have reported 200% faster load times post-migration to their platform. What I find cool about Kinsta is their fast and reliable customer service and premium features that are included at no extra cost. Ready to experience Kinsta's hosting for yourself? Get your first month free when you sign up at kinsta.com today. That's KINSTA.com.
So how, from that initial MVP, how did you progress the product? How have you matured the product from the initial prototype?
We had a lot of, I would say, informative failures over the prior few years leading up to the looking glass. And when we make a prototype system, if it gets past a certain level of belief and excitement internally in the team, then we'll typically make anywhere between a few dozen to 100 of those prototype systems, and we'll try to sell them. That's one thing that we do that's quite unusual, I would say, is we've sold a lot of these prototype systems over the last 6 years or so of the company's life. And that let us see how folks out in the world responded. Like, oh, do people actually need to reach into the light field and manipulate it? What's the resolution requirement that's needed for X, Y, or Z application? Those types of things. Do people feel eye strain? Or is it completely comfortable for anybody to look at all day long? All of those things were fed into ultimately making that system of the looking glass. And so we made the first prototypes. We got excited about it internally in the team. We do hardware at the same rev speed as our software development. So we were able to basically release usable dev kits a few months later to, a few dozen developers that in some cases they'd gotten our earlier prototype systems. In some cases it was someone we met at a trade show. We're like, hey, we got this thing, like come behind the curtain, you want to check this out? And we would sell it to them on the spot. It was all laser cut stuff and so on. That then gave us more confidence in how we were pricing the systems and so on, that we actually did a Kickstarter in 2018 for the looking glass. And that approached $1 million, and it got thousands of developers to have this first generation holographic display, which frankly everybody thought was impossible. So having those systems out in the world let us prove that this was actually the real deal, that this wasn't snake oil. And that's let us develop the subsequent systems over the following year and a half or 2 years.
So how did you go about building your roadmap? How do you figure out what's the next most important thing to build for looking glass?
We built larger systems. So after we built the desktop dev kit system, we knew something that was important to understand was a larger holographic display that was less of an object on somebody's desk and more of a holographic window that could connect the real world with, an unseen 3D digital space, or in a not so distant future, possibly connect places in the world to one another. So we pulled everything that we learned and developed in those first generations of our hardware and software stack into something called the Looking Glass 8K. But we announced and showed that at CES, and people got really excited about it because the scale of it, this thing's 32 inches in size versus the 9-inch systems that were the first dev kits. So it's much larger and really does let you have that view into a holographic world that is different in a lot of ways from the desktop models. So that was a pretty obvious step that we needed to take. There are additional steps in the future, which some are obvious and some are less obvious, such as the obvious ones are, we're a universal output device. So anything that runs in 3D, we want that to be able to run in the looking glass. So we've already connected up with Unity and Unreal, 3JS, all of these developer tools and engines that let folks make and deploy holographic apps. But we also wanted to tie in with the way folks work now in 3D. For instance, a couple months ago, we announced this partnership with a company called Schrödinger. They're the world leader. They're based in New York as well. They're the world's leader in molecular modeling and computational chemistry. Basically, all the big pharma companies use this stuff to design drugs in computers rather than, in physical medium. We were able to work with Schrödinger so that now someone who's using their software platform, they can plug in a looking glass and have an instantaneous view in the looking glass of what they're working on in the design of those new treatments, but they can view it holographically, which is vital for molecular modelers and others in that industry. And we're going to continue to do that in more and more industries over the coming months, so that the looking glasses that are out there and the ones that folks buy fresh, they'll become more and more and more useful over the coming months. There's some less obvious moves that we're interested in. Our path is really similar to the path that, desktop computers took in the 70s and 80s, where we start with a highly engaged group of developers, of which most of us in the team we're part of that community. So we understand what it's like to be part of that community quite well. And then we move into enterprise, which we're doing like that example of molecular modeling that I gave. And we're going to be doing that in more and more industries over the coming months. But then the last step to where everybody is using a holographic display in their homes and schools, and it becomes a primary interface for people's lives, that's something that we are very focused on achieving. So we will not be satisfied if we stopped at the enterprise phase. Our goal is for holographic display to be the ubiquitous interface for the next generation that really does impact billions of people's lives. And so we're always developing experiments and whatnot that sort of poke into that future as much as we can.
So let's switch gears a little bit. So you mentioned, there's a team in the US and a team in Hong Kong. And what I'd like to know is how you went about building that team. And in particular, what did you look for in these people to indicate that they were the winning horses to join the team?
I'll straight up say that our team we're very much the island of misfit toys, I think. So it would be hard to recreate how special and powerful the Looking Glass team is. A lot of folks in our software team, they are artists, and they taught themselves programming because they wanted to become better artists. And a lot of folks are game designers, and same sort of story. They learned how to become world-class programmers because they wanted to make world-class games out of pure love, not for any other reason. I actually don't know where anybody, other than my co-founder Alex, I don't know where anyone in our team went to college. I'm sure I looked at it on the resumes at some point, but I don't remember it, and I don't think anyone in the team does either. The only things I remember about when we hire someone is what they've done. One of the lead folks in our team, Kyle, who built our Unity SDK, which is our most popular software pipeline for generating holographic apps for the Looking Glass. He went to art school and he made a few games. And before I interviewed him, I just played his games on an iPad or a phone, I can't remember. And they were so awesome that I hired him on the spot. And that's sort of the story of how everyone in the team ended up being hired. Our lead mechanical engineer, for instance, I printed out, I mentioned that Edison was one of my heroes from back in the day. I know there's a whole Edison Tesla. I like both Edison and Tesla. And Hedy Lamar and a whole lot of other inventors from those days. From one of Edison's patent drawings for the phonograph, which is my favorite invention, I printed it out. And I printed out Edison's original terrible sketch that he had given to the lead engineer and his team to build this thing that he had dreamed up to record human voice. And I don't know, I had maybe 6 or 10 folks crack open SolidWorks and draw three-dimensional workable version off of Edison's first drawing in, I think it was a half an hour test or so. And Angus is the lead mechanical engineer in our team. His was by far the most astounding. And so, we hired him essentially on the spot too. So that's how we try to have the evaluation criteria be real rather than be imagined, like what is on a lot of folks' resumes just doesn't matter a whole lot unless it kind of indicates what magical things they've made and what they're passionate about and what they can do.
So let's talk about scalability a little bit, and it's going to be interesting to see how this plays into Looking Glass Factory. Did you build this to scale efficiently from the beginning, or is that something you're starting to think of as you start to gain more and more traction with your current model?
I mean, it's definitely let's get this working. Let's figure that out later. But we do, I would be lying if I said we weren't ambitious as a team. I think anyone who's aiming at a goal like this has to have some level of unreasonable ambition in their hearts to keep driving forward. So especially with a new interface like this, scale does matter. So unless a lot of folks are awash in the magic of a holographic display, you don't have enough of an install base to actually drive that to its perfect conclusion of making it all that it can be. If only, a few hundred people are using these systems, then you're never going to be able to put enough resource towards it to refine those applications, to become world-class, to unlock as much magic as this new type of interface can potentially deliver to the world. That's a long-winded way of me saying that scale is always in the back of our minds, but when we deploy so quickly that we can't really plan for everything. So we have tons of technical debt that we end up having to, shovel our way out of. But the more important thing to us is seeing what sticks and then shoveling our way out of the mess that we've made for ourselves as fast as possible.
So as you step out onto the balcony and you look across all that you've built with Looking Glass Factory, what are you most proud of?
I'm proud that we figured this out, because when we started the company, actually nobody thought that this was possible, including folks who started AR and VR headset companies. So if you read some of the old interviews from, the founder of Magic Leap and, Palmer at Oculus and so on, this dream of holographic display was something that, all of us had. But everyone thought that it just wasn't going to be possible for 50 years or 100 years. And so when the team and I were trying to convince folks that this was something we wanted to do, we had people laugh at us, I guess is what I'm trying to say. In a very literal sense, people literally laughed in our faces when they would see the early prototypes of what we would make. So having everyone in our team psychologically overcome all of those challenges, and actually to achieve the first commercial holographic light field display is something that, we're all really proud of it. We will be extremely disappointed if we don't push this to the full limit, where there are many, many millions of these systems delivering holographic enjoyment and magic and power into all of the businesses and homes around the world. But in terms of what we've done so far, actually getting a system out there that people are using every day, and one that nobody knew was possible, including us, is something that is pretty cool.
Okay, let's flip the script a little bit. Tell me about a mistake that you made and how your team responded to it.
There were certainly some systems that we launched that, in retrospect, we maybe could have learned more of what we needed to without putting so much effort behind it in terms of a full-scale launch. So there are a number of prototypes that led up to the Looking Glass that we did full-scale launches of, and they failed. So they would only sell a small handful of systems, either because they were too expensive, or they were too low resolution, or we couldn't get across what they could do over 2D video on a launch platform. So each failure like that is actually pretty psychologically damaging for everyone in the team that pushes towards it. So to overcome that takes a huge amount of energy, and we're able to do it. And I'm sure that's going to continue to happen in the future. So it's hard for me to say that those were mistakes. Knowing what I know now about the results of those experiments, I would say oh yeah, sure, we could have saved ourselves a lot of agony and not done that. But at the time, I think those were essential steps to have taken. I think the big mistakes are potentially in the near future here, where we're having to adapt really quickly to a very changed world. So if you think about what we do as holographic display, it's hard to describe a holographic display over voice as we're doing now, but it's also extremely difficult to do over 2D video or a website. So in the past, we were actually known in sort of this field of AR, VR, hologram land, of being the team that would, just set up a looking glass everywhere. Like we were in, taco bars and every trade show, and just all over the world, we were flying these things around and showing them around to be able to prove that what we were making was the real deal. And we can't do that now. That has really changed a lot of our thinking on how we need to expose folks to the power of a looking glass hologram. And so we'll see whether those moves that we're going to be making in the coming few months will actually stick or not. So I think that's one of the big things that'll determine whether or not we're successful or not. And I think, there's a chance that we'll make some big mistakes there.
Mistakes are not easy, but to see the value in them afterwards is a really important thing. Sounds like you got a really good handle on that. Shawn, tell me a little bit more about you. So who influences the way that you work? CEO, CTO, you mentioned some influences earlier when we were talking, but tell me who influences the way that you work, a person you look up to and why.
Well, my mentor at MIT is a professor. Her name's Amy Smith, sort of famous in the world of very low-cost technologies for emerging markets, developing countries. My thinking about how to invent and how to work with teams around the world was really influenced very heavily by what Amy did. She developed a department called D-Lab, which focused on this type of different way of inventing teams around the world and with different cost constraints and so on than you typically would have when you're designing something in single office or single lab in Silicon Valley, which I view basically negatively as a monoculture in most cases. So that's influenced how we've developed Looking Glass, and there's certainly a lot more that we have to do on that front. In startup land, I commiserate with a lot of my peers. So it's more about the shared stories of what we're all going through. There's other examples of obscure invention heroes that I've had the benefit of working with over, the past 15 years or so that I don't think your listeners are going to know, but each of these folks ended up influencing heavily that idea that the best way to invent is really to have different teams from different backgrounds working together on a shared mission towards something that is very difficult to achieve, and to do so with an eye towards different constraints than other groups might have had.
So if you could go back to the beginning, where would you consider taking a different approach?
I might have started 3 years later. I think that all of the factors that ended up flowing into making the Looking Glass possible today, they just weren't around when we started the company 6+ years ago. And so we made all of these systems struggling to achieve this goal where, the stuff that was available to the computers that could run and calculate the holographic light field or whatever method it was that we were doing at the time, volumetric display, et cetera, to achieve that goal of the hologram, they weren't up to the job. So I think we learned a lot in those few years, but we probably could have gotten to a similar destination point if we had just started 3 years later. That being said, part of the reason that I run the company the way that I do, and that we have particularly low burn rate and things like that, is to buy us time. I'm a believer that things that are huge swings, they take time to do, and you don't know exactly when everything's going to converge to make the magic happen and lead to adoption by millions of people. So we try to buy as much time to run as many experiments as we possibly can in order to have that magical timing that everyone hopes for in startup land. So, but I do wish, maybe we could get those first 3 years back.
You're getting on a plane and you're sitting next to a young entrepreneur who's built the next big thing. They're jazzed about it. They can't wait to show it off to the world, to show it to you. Maybe they're on their way to an investment meeting or not. What advice would you give that person having gone down this road a bit?
I always encourage folks to make the jump into running a startup, becoming an independent inventor, whatever the modality is that they feel will work for them. If someone's passionate enough to talk about it and, on a plane, they probably could have what it takes to push through all of the challenges of making that dream real. I think so many folks give up on their dreams because someone knocks it down at an early stage. I will never be the guy that does that, regardless of what the idea is. Because what do I know? Maybe there's something to it that I don't see in that moment. So I would say do it. And it's going to be I'm sure everyone says this, it's going to be an unbelievable amount of work. But at the end of the day, you then become a creator. And not everyone, actually very few people in the world get a chance to be a creator of something new that no one thought was possible. And that's something that should really be treasured and pursued with all of one's might and force, if they have that dream in their heart that they want to try to achieve.
That's great advice. Well, Shawn, thank you for being on the show today. Thank you for being on Code Story and telling the product creation story of Looking Glass Factory.
Yeah, thanks for having me.
And this concludes another chapter of Code Story. Code Story is hosted and produced by Noah Labhart. Be sure to subscribe on Apple Podcasts, Spotify, or the podcasting app of your choice. Support the show on patreon.com/codestory for just $5 to $10 a month. And when you get a chance, leave us a review. Both things help us out tremendously. And thanks again for listening.
Business taxes. Was stressing about all the time and all the money you spent on your taxes.
This is my bill?
Now Business Taxes is a TurboTax small business expert who does your taxes for you and offers year-round advice at no additional cost, so you can keep more money in your business. Now this is taxes. Intuit TurboTax. Get an expert now on TurboTax.com/business. Only available with TurboTax Live Full Service.